Hey there, this is Dr. Golding. Um, we're going to continue our logic class, and I think what I'm going to do is a few of the exercises from the end of 6.6, and this is what you had for homework last time. And also, I'm going to go on to talk about 7.1. So first, let's go to 6.6, the exercises. I'm going to do a few on the board, numbers 2, 6, 11, and 14 in the book. Okay, so here is what number 2 looks like. It is the following. Now, I'll write this on the board. We have S horseshoe F, F horseshoe not L, and we have S horseshoe not L. So what you're supposed to do in these exercises is determine whether, again, this is number 2 from 6.6. So what you're supposed to do here is determine whether this is or is not a valid substitution instance of one of the argument forms that we learned in 6.6. Is it a valid argument form or not? So maybe it would be a good idea to put down on the board all of the valid argument forms that we have. Let's see, we have modus ponens, which is this, right? You have a horseshoe and you have the antecedent, that's modus ponens, abbreviated MP. We have modus tollens, which looks like that, right? That's modus tollens. You have a horseshoe, you have the negation of the consequent, you're allowed to infer the antecedent. We also have disjunctive syllogism, which is P wedge Q, not P, therefore Q, or P wedge Q, not Q, therefore P. I think I told you that there are 2 forms of disjunctive syllogism, really. And then what else did we have? We had the hypothetical syllogism. Hypothetical syllogism involves 2 horseshoes, P horseshoe Q, Q horseshoe R, therefore P horseshoe R. That's HS, hypothetical syllogism. And there was another rule that we learned about, which is called, let's see, constructive dilemma. Do they have that here? Yes, constructive dilemma is a little more complicated. You have P horseshoe Q and P horseshoe R. Excuse me, that's wrong. P horseshoe Q and R horseshoe S, P wedge R, therefore Q wedge S. That's called constructive dilemma, or CD. Those are the valid argument forms. You also have destructive dilemma. Okay, destructive dilemma is where you have P horseshoe Q and R horseshoe S, and then you have a disjunction with the negations of the 2 consequents, and then the inference is to not P or not R. That's destructive dilemma, or DD. Okay, hope you can see all of these valid argument forms. Of course, are in the book. So now what we're doing is we're looking at this, and we're asking ourselves whether this is or is not an instance of one of these argument forms. So what we have here is 2 horseshoes and a 3rd horseshoe. Well, the only one that it might match up to would, of course, be hypothetical syllogism. Does it fit the pattern of hypothetical syllogism? I think the answer is yes, because what you have here is what we call the middle term, right? This is standing in for Q. You have S horseshoe F, F horseshoe not L, So if we let S be P and let not L be R, you would end up with P horseshoe R. So it does count as a valid example or a correct substitution instance of hypothetical syllogism. Right? You have two horseshoes. The consequent of one is the same as the antecedent of the other, and the conclusion is the antecedent of the first one and the consequent of the second one, so it matches the pattern of hypothetical syllogism. So the answer is yes, number 2 is correct. It is a valid argument. It follows the pattern of hypothetical syllogism. Okay, let's go on to number 6. I'll leave the argument forms on the board. Number 6 is, let's see, M wedge not B, not M, therefore not B. This is number 6. We have M wedge not B. Looking at my book, not M, therefore not B. So we have a disjunction. And we have the negation of the left-hand side, and then as our inference, we're inferring the left-hand side, right? The tilde here is part of the original formula, tilde B. Does this look like anything that's a valid argument form? The answer is yes. It is actually this version right here of what we call this disjunctive syllogism, DS. So we would say, yeah, because you have a disjunction, the negation of the left-hand side, and you inferred the right-hand side without adding another tilde. Okay, so this is disjunctive syllogism, correct? That would be the answer to number 6. And let's see, number 11 is a little complicated. Number 11 is we have K wedge B dot N wedge Q, and we have K wedged N, therefore B wedge Q. So let's look at this carefully. We have a conjunction of two disjunctions. Conjunction of two disjunctions, and then we have a disjunction of the first one here and the second one here, and the result is the last two disjuncts in the original formula brought down here in a new disjunction. So it looks like maybe something like one of these, but look at here, this one is a conjunction of two horseshoes. So this is a conjunction of two disjuncts. So this is bad. This does not match any of the valid argument forms that we have on the board. And in fact, this would be an invalid argument. If you did a truth table for this, you would find that it is invalid. So again, the problem is, just looking at it, these two things are disjunctions. If it's anything, it's going to be this one, but these are horseshoes. So therefore, this is not a valid argument at all. It is not a correct substitution instance of any of these valid argument forms. Okay, we're going to do one more from this section, number 14. Let's see what number 14 has to offer. B dot T, T, therefore not B. This is number 14. B dot T, T, therefore not B. Okay, so we have a conjunction, and then we have the left-hand side of that conjunction, and we inferred the negation of the left-hand, we have a conjunction, the right-hand side, T, and we inferred the negation of the left-hand side. Now, this is bad. Maybe you could fall into the mistake of thinking it looks like disjunctive syllogism, but this is a conjunction. And so you cannot infer the negation of the left-hand side of a conjunction by knowing that the right-hand side is true. This would be an invalid argument, right? This is saying B and T are true. T is true, therefore not B. So this would definitely be an invalid argument. It is not a substitution instance of any of our valid argument forms. So if you're having any trouble with this, call me, email me, take a picture of your work, send it to me if you're not sure you're doing them correctly. I thought I would do a few of these on the board just to make sure that we're getting the hang of these things. So right now we're going to go on to unit or chapter 7. Now what's going on in chapter 7 is that you're beginning to learn something called the proof method for showing that certain arguments are valid. We had learned the truth table method, right? Let me erase the board here for a second. Actually, I'm going to leave these up on the board because these actually are going to become rules of inference in our system of proving arguments. Now, basically, the idea of a proof is that you have a set of premises and you can show step by step that the premises do indeed lead to a certain conclusion. The proof method involves learning certain rules of inference. We're also going to talk about replacement rules, but we'll get to that later on. We're going to start with rules of inference. A rule of inference is basically an argument form, which is a valid argument form, that allows you to move in a proof from one step to the next. So we're going to define a proof. A proof in symbolic or propositional logic is a series of steps in which you start off with premises and there's some last step, which is the conclusion, and in a valid proof, in a good proof, each step is justified by a rule. So you got to learn certain rules, and then you have to learn how to construct a proof in propositional logic using the rules that allow you to get from premises to a conclusion. So the first step here is going to be learning some inference rules. Now basically, in this section, we're talking about 7.1. Okay, what we're doing now is 7.1 in the book. There are, I think there's 5 rules that you learn in 7.1. So the first important thing is just to get the rules down, how the rules work, and then once you learn the rules, you begin to construct proofs using those rules. So this is entitled Rules of Implication number 1, because there's going to be a bunch of rules of implication, and so this is the first set of rules of implication that you're going to learn. And let's see, it looks like there's modus ponens, modus tollens, pure hypothetical syllogism, and 2 versions of disjunctive syllogism. So did I say there are 5 rules? It looks like there's really, there's 4 rules, so we can get rid of some of this stuff. This is not going to come up in 7.1, and I don't think this comes up in 7.1. Now again, with disjunctive syllogism, you really have 2 versions of disjunctive syllogism, right? But these are basically the first 5 rules of inference that you're going to learn. Modus ponens can be looked at as a rule. Whenever you have these 2 steps, or anything that has that form, you would be allowed to infer the consequent. And so on for all the other rules. Whenever you have an instance of the 2 premises, you would be allowed to move to the appropriate conclusion. So the best way to sort of get the hang of this is by doing some examples. So let's see, I'll tell you what, we're gonna what I was going to ask you to do for homework is to look at exercise 7.1 and do Roman numeral 1 and Roman numeral 2. We're just going to ask you to do Roman numeral 1 and Roman numeral 2. We're going to take this slow. So this is the homework, Roman numeral 1, Roman numeral 2 in 7.1. Now, if you can do this on your own, by yourself, without listening to me any further, that's fine. You could try to do it, maybe pause the video right now, go to 7.1, try to do some examples of Roman numeral 1, and try to do some examples of Roman numeral 2, and then turn the video on back, and I'm going to do a few of the exercises right now. Okay, so if you want to pause the video and go for it, go ahead. If you want to just watch me do a few of them and then do the rest of them for homework, that'll be fine too. So I'm looking at exercise 7.1, and I'm going to start off with number 1. It says as follows. You have, let's suppose you have, right now I'm doing from Roman numeral 1, exercise number 1. Suppose you are given the following 2 steps, G horseshoe F and not F. You're given G horseshoe F, you're given not F, and the question is, what can you infer using one of the rules? Now right now we're only talking about these 5 rules, hypothetical syllogism, modus ponens, all right, this is modus ponens over here, just to make that clear. Hypothetical syllogism, modus ponens, modus tollens, or the 2 versions of disjunctive syllogism. Is there anything that you can infer over here that would be a correct use of one of the rules? So, for me, since I've been doing this for a while, the answer is very, very obvious. I look at this, I see that this is a horseshoe, and I see that this is the negation of a consequent. Well, that matches up with modus tollens, right? Modus tollens has a horseshoe, the negation of the consequent, and I can infer the negation of the antecedent. So I'm going to write down here the correct answer would be not G, right? We need the negation of the P term. G is the P term. Negation P matches up with negation G. So this is a very clear and obvious example of modus tollens. So I would say, by modus tollens, I can infer not G. So that's why the book gives you a little blank, what can you infer? And then there's that little blank on the side over there, if you notice in your book, so that you would write down MT and not G as the answer to what you can infer. Okay, let's do a few more. Something maybe a little bit more, well, let's just do number 2. Number 2 is pretty easy, I think. You have S, again, now I'm doing number 2. You got S, you have S horseshoe M, and what can you infer by which rule? So this is a horseshoe. This is the antecedent of the horseshoe. Well, the rule that would match up with is modus ponens. And the correct inference would be, I would say, M, using the rule of MP, modus ponens. Okay, M here is just a constant. MP here is the abbreviation for modus ponens. So that would be the answer to number 2. Let's try something maybe a little bit more messy and complicated. Let's go to number 8. Now, in number 8, you have several premises or several steps, and you have to sort of dig in there and see what you can do. And in some cases, like this, one of the steps is going to be just extraneous. It's there to, in a way, just sort of mislead you. Excuse me. So let's look at number 8. I'll write it on the board. This is number 8. It looks like this. We have S horseshoe W. That's number 1. Then we have not S. Then we have 3, we've got S wedge N. And now we're supposed to say, okay, what can I infer and using what rule? So I'm looking at this and I'm saying to myself, well, I have a horseshoe here, S horseshoe W. This is not S. Now, this is not going to work for modus ponens because what I would need is S to get W. If this was just a plain S without the tilde, I could infer W using modus ponens, but I can't do that because this is not S. However, I look at 3, I see, aha, I have a disjunction, and I have the negation of the left-hand side. What is that? That matches up with DS, disjunctive syllogism. So I'm going to say N, because that's what you can infer, is if you have the negation of the left-hand side, you can infer the right-hand side by itself without adding on a tilde. And I'm going to say disjunctive syllogism, and I'm going to say 2 and 3. Now what that means is I'm saying disjunctive syllogism using steps 2 and 3. I'm not using step 1 here. Step 1 turns out to be irrelevant or extraneous. I didn't use it to get to N. But I did disjunctive syllogism on steps 2 and 3 to get N. Now, as we'll see later when we start doing proofs, you can have a proof that has many, many steps, 18 steps, in some cases 25 steps. So proofs can get long, but as long as each step in the proof is justified by a rule, if you get from the premises to a certain conclusion, then you would have a correct or a valid or well-constructed proof. Okay, so you're going to have to get used to this idea of having steps. You can have a whole list of steps, and you have to kind of look through and see how to get the next step toward the desired conclusion. Anyway, we don't want to get ahead of ourselves. Let's just do another example from this set. I'm going to try... Now, sometimes I think the book says... Well, the book says there's only one possible answer for each problem. Okay. In some cases, you can have a list of steps, and there's different things you can do using different rules. But in this set of examples, there's only one correct answer, or at least that's what the book seems to be implying. I think I'm going to pick one from later on in 7.1, Roman numeral 1. I mean, a later example that has more premises. Let's try number 14. Okay, I'm doing 7.1, number 14. Number 14. We have, okay, N horseshoe not E. We have tilde tilde S. Now you might think that's an odd way of speaking, but you're going to have to get used to this, that sometimes you'll have double negations in front of things. You could have 3 negations. This is, if you recall the idea of a well-formed formula, this is well-formed, right? S is a component, S is a statement, not S is a correct or well-formed formula, and now you have not S. So this, let me just write this again more clearly, not S, this is a perfectly valid, maybe valid is the wrong term, this is a well-constructed formula. Okay, that's number 2, not S. Now you have step 3 is not E, wedge not S. And then number 4 is not S, wedge N. And you're asked, what can you derive as a next step and using what rule, and on which steps would you be using that rule? Okay, so let's see. What do I have here? I'm looking at the first step as a horseshoe. To do something with that horseshoe, I would need either N, and then I could use modus ponens, or I would need not E, and then I could do a modus tollens and get not N. Now, I don't have in my other list, or the rest of this list here, I don't have N, I don't have not E. So one thing that's important to realize is that, and maybe this is obvious, but I'll say it anyway, is that if I go over here, I see that n is over here, right? So could I do a modus ponens on 4 and 1? Because I say, well, n is over here, so why can't I do modus ponens on this n and number 1? So that would be incorrect, because you don't have n. All 4 says is not s wedge n. You don't even know if n is true, right? If you were just given this statement, you don't have n. You have not s or n. So it's a very important thing to bear in mind that you cannot do an inference rule on part of a formula. Maybe to say that better, you cannot use parts of formulas when doing inference rules. You have to have n by itself, and of course n horseshoe not e, you could get not e. That you'd be allowed to do, but you can't go into a formula and take something out and then use it as in order to make some inference. Okay, so I don't have a modus ponens here. I don't have a modus tollens here. Maybe there's something I can do with these wedges. You have 2 wedges, 2 disjunctions. Well, you can't use hypothetical syllogism. That's with horseshoes, not with wedges. So the only thing I'm seeing here is I have not s. And did the book say there was only one correct answer to this question? Because it's looking to me like in number 14, actually I think the book made a mistake. There are, unless I'm missing something, oh, I know why. Okay, because for me, I've told you that you can do disjunctive syllogism in either one of these 2 versions, right? So, therefore, according to the way I would have it, you can do disjunctive syllogism on 2 and 3. That would be this version of disjunctive syllogism. You can also do disjunctive syllogism on 2 and 4. Right? You have a disjunction. This is what the book wants you to do, because they're saying this is the real disjunctive syllogism, only negating the left-hand side and then deriving the right-hand side. Okay, so if I do disjunctive syllogism on 2 and 3, I then come up with not E. That would be the answer. I also think if we allow ourselves to do disjunctive syllogism this way, then you could do disjunctive syllogism on 2 and 4, and you would come up with N. Okay? Because I have the let's see, I think I said it backwards. This is the way the book would have you do it. Do disjunctive syllogism on 2 and 4, and you have the negation of the left-hand side, you infer the right-hand side. This is what the book wants you to come up with. What I was saying was that if you do disjunctive syllogism on 2 and 3, that would be this version of disjunctive syllogism, then you would get not E. So don't worry about this right now, because in the end, the book is going to say later, there's a rule called commutativity, which allows you to flip around the order of a disjunction. So in any case where you're going to be able to do this, you would just flip around the order of the wedge and do this version of disjunctive syllogism. Don't worry about this right now. The main thing is to try to get the hang of applying the rules as best as you can. So those are some examples from 7.1. Maybe I'll do one more. We'll do one more here from 7.1. Let me find my eraser. What did I do with it? Here it is. Maybe I'll just leave these numbers up. Let me try something like, I'll try number 18. We'll do number 18. Here we have R horseshoe M horseshoe D. We have M horseshoe C. We got D horseshoe M wedge E. We have not M. And the question is, what can you infer? I hope this is clear. R horseshoe M, horseshoe D, M horseshoe C, D horseshoe M wedge E, and not M. And we now have the question, what can we infer and using what rule on which step or steps? So, can I do a modus ponens on 2 and 4? I have M horseshoe C, I have not M. So I cannot do modus ponens on 2 and 4. Modus tollens, I would need not C. So, I don't have D, I can't do modus ponens on 3. I don't have not D, I can't do a modus tollens on 1. What I do have here are some horseshoes, so I'm beginning to think that maybe what we're supposed to be looking for is hypothetical syllogism, which involves using 2 horseshoes. Now be very careful here. What would be a good use of hypothetical syllogism? Well, I have to have 2 horseshoes where the consequent of one is the antecedent of the other, and indeed I have that, right? D here is the consequent, and over here D is the antecedent. So the correct thing to infer would be the first antecedent horseshoe, the consequent. Again, D is what I call the middle term, it's like the Q, so you would end up with P horseshoe R, and so I would say as follows, R horseshoe M, that's the whole P term, horseshoe M wedge E. That whole thing would be the answer, and I would say hypothetical syllogism using steps 1 and 3. Hypothetical syllogism on 1 and 3. That is the correct answer to number 18, and I think that's the only correct answer in this case, like the book says. Okay, I hope everybody can see that. R horseshoe M wedge E, the antecedent of the first one, horseshoe, the consequent of the second one, hypothetical syllogism on 1 and 3. Okay, do all of the other examples when you can from 7.1. Let me just restore what I erased here. This is P wedge Q, and this is disjunctive syllogism. Okay, so now we're going to do some examples from 7.1 number 2. And again, if you want to pause the video and try to do them yourself, that would be fine. If you want to see me do a few of them, and then try the rest of them yourself, that's also fine. What you're supposed to do here is you're given a premise, then you're given a blank, and then you're given a conclusion. And you're supposed to come up with, what would I need in order to get that conclusion using the stated premise? So for example, here is in 7.1 number 2, we're going to do number 1. Here we have B wedge K, and now we have step 2 blank, and the desired conclusion is K, and the question is, what would I need as my step 2 to get K out of 1 and 2, and by what rule would I be doing that? And so the simplest thing, your book says, try to look for the simplest formula and the quickest, easiest way of getting to the conclusion. Well, this is a disjunction. So it's going to have to be a rule that involves disjunction. It's going to have to be disjunctive syllogism. That's the only rule that we have, at least so far, that involves a disjunction. What would I need to get K? Well, I would need the negation of the left-hand side, right? I would need not B. That would allow me, if I had not B, I would be able to get K by a disjunctive syllogism, obviously on 1 and 2. Those are the only 2 steps here. So the answer is, I need not B, and then I would get K by disjunctive syllogism. Okay? Let's try, I'm gonna skip to number 3. Again, you should try to do all of the ones in Roman numeral 2. They get a little more complicated or harder as the exercises go on. What's with number 3? Let's see here. With number 3, we have K horseshoe T. We then have blank. And what do I need in order to get not K? Okay, and by what rule? Well, I have a horseshoe. The only way I can get a negation of the antecedent, that's what this is, not K, is going to be something like modus tollens. In fact, it's going to have to be modus tollens. That's the only correct answer. The only way I can get not K out of number 1 is if I plug in not T and say modus tollens. So that is the correct answer to number 3. Let's try something a little bit more challenging. They get more challenging when there's more steps there to sort of distract you and make you wonder like which one is the correct line to use. So I'm going to skip down to well, let's look at number 7. Okay, I'm looking at number 7. This is the following. I have M horseshoe B. I then have Q horseshoe M. And I also have, here's my blank. And then what I'm looking for, I'm trying to get M. Okay, how can I get M out of 1 and or 2? Now, with these exercises, some of the steps might be extraneous or irrelevant. Is there some way of getting M out of 1 and 2? I don't think so. The only thing you could do with 1 and 2 is do a hypothetical syllogism. You look at M as the middle term, you could get Q horseshoe B by a hypothetical syllogism on 1 and 3. Remember, I told you the order doesn't matter. The main thing is that the antecedent of one is the consequence of the other. So using hypothetical syllogism on 1 and 2, did I say 1 and 3? Sorry. 1 and 2, I could get Q horseshoe B, but that's not what I was asked to get. I was asked to get M. How in the world can I get M out of these two? Well, out of these two alone, you can't get M. The question is, what would I need if I had something else over here? What would it be such that it allows me to get to M? And it looks to me like the answer is, I'm looking over here, I see we have a horseshoe. M is a consequent. Well, if only I had Q, right? Then I can do a modus ponens on 2 and 3, and I would get M. So the answer is Q. Using a modus ponens on 2 and 3, I would be able to get M. It turns out that number 1 was irrelevant or just there as a distraction, not playing any role in getting M, at least not in this case. Okay, let's see. Let's try something maybe a little bit more complicated and confusing. I'll skip down to number 12. Here's number 12. We have G horseshoe C. We've got M wedge G. We've got H wedge T. Blank, that's what I'm looking for. And 5 is F horseshoe. I'm sorry, I messed up here. Sorry about this. We're doing number 12. We have G horseshoe C, M wedge G, T wedge, not G. 4 is the thing that I'm trying to find, and we have G. What rule, using what formula over here, would I be able to get to G? So, I can't get G out of number 1, even if I had, let's suppose I have C, that's not going to work, right? G is the antecedent here. If this was not G, I could then do not C and use modus tollens, but G is over here. The trick to doing these in a way is to look at your desired result and go back into your formulas and see where you see it. I see that G is sitting over here. Now it's also sitting over here, but I can't get it out of number one even with any other formula. So G is sitting over here. This is a wedge. If I have the negation of M, then I could get that by disjunctive syllogism. So the correct answer is going to be not M, using disjunctive syllogism on 2 and 4. Okay, that's the correct answer to number 12. Not M, using disjunctive syllogism on 2 and 4, I would be able to get G. Okay, so I think this is enough for one session. We have not gotten to Roman numeral 3 yet, but my suggestion, my request to you is that you do exercises, again, from 7.1, Roman numeral 1, and Roman numeral 2. Okay, that's the homework. And next time we'll talk about what's going on with Roman numeral 3. Essentially, in Roman numeral 3, you're asked to do proofs. You're given a set of premises, you're given a desired conclusion, and you have to come up with the rules and the applications that will allow you to get from the premises to the conclusion. And that's constructing a proof. Have a great day, and I'll speak to you in a couple of days from now. Bye.